In our next objective, we're doing the exact opposite pattern of objective 1. Here we're looking at balanced equations and trying to turn every symbol into a word. It's really just practice with nomenclature. First one I'm seeing is 2NaI, little aq. Turning those into words, we have to name the compound NaI. Na, of course, standing for sodium. I is in iodide, and it's aqueous. So I'm going to begin my sentence by writing aqueous sodium iodide. I see the and sign. On the left side of the arrow, the and is reacts with. We need a verb. So our sentence has a verb when we write reacts with. Aqueous sodium iodide reacts with. See that little L standing for liquid and the molecule called bromine. Reacts with liquid bromine. The arrow with the word heat on it. So I'll put a comma, when heated. Aqueous sodium iodide reacts with liquid bromine when heated to form aqueous sodium bromide. And now the plus will be the word and. I2S will write solid iodine. Iodine is in an elemental form. Bromine is an elemental form on either side. Aqueous sodium iodide reacts with liquid bromine when heated to form aqueous sodium bromide and solid iodine, turning each of our symbols into words. Reading number 2. Al2O3, little s, PT on top of the arrow, making Al and O2 gas. So each one of these, one at a time, we'll name. Al2O3, with a little s, I'll start by writing that solid. Al stands for aluminum. And this binary compound ends with "ide." This is solid aluminum oxide. Then I go straight to the arrow. This pattern of change, if I have a single reactant breaking down, is called decomposition. So to make my adjective work here, every sentence needs some sort of verb, right? Solid aluminum oxide, what is it doing? Well, it's decomposing. So solid aluminum oxide decomposes, and I see that PT, that's the element platinum. PT is right off the periodic table. The element is platinum. Since it's sitting on top of the arrow, it's a catalyst, something we add to an equation to make it occur faster, providing an alternate pathway for the reaction mechanism. So it decomposes in the presence of a catalyst. Then I'll write to form for the arrow. Lots of choices. I'll write to form. And I see that it's forming solid aluminum. And the plus sign will be the word and. O2 with a little g, the oxygen gas. Notice that I do not have to write about the coefficient out front. Hearing the words will allow us to change those words into a balanced equation, but they do not have to be part of our sentence. Alrighty, so just naming the compounds and describing what's going on using verbs and adjectives, not necessarily numbers. Number 3, N2O3 is a molecular compound built of 2 nonmetals. Binary molecular compounds use prefixes. I'll start this sentence by saying solid dinitrogen trioxide. Hear those prefixes indicating molecular compound. The plus sign will be reacts with, so we have a verb. liquid water for the H2O little L, liquid water. Then the arrow, you want to say yields, forms, produces. I'll say forming. Solid dinitrogen trioxide reacts with liquid water, forming. Then I notice I have an acid. This is a compound that starts with an H. Nitrate is the polyatomic ion. 8 turns to ic, and we get nitric acid. And let me just stress here, acids are always aqueous. It's redundant to write aqueous acid. You may certainly do it, I wouldn't mark you wrong, but it's not necessary for acids to say that they're aqueous. We know they are. Solid dinitrogen trioxide reacts with liquid water, forming nitric acid. Pattern of change looks like a combination. We produced a single product. By the way, let's back up and do that because it's just good practice to recognize the patterns. Two things combine to form a single product, combo. One reactant breaking down into simpler substances. This is a decomp. Here I have a compound plus an element making a new compound plus an element. Bromine kicks out iodine. The nonmetal kicks out the nonmetal. This is a single replacement. Element plus compound made a new element and compound. This would be the picture of the dog dropping the bone to pick up the steak in our cartoon chemistry. We'll go on to number 4. We have aqueous solutions going on here. Finally, we have a solid, the driving force of a double replacement. Notice how sodium goes to nitrate, silver went to chloride as we formed our two products. I'm recognizing a double replacement pattern. Two compounds where the positive ions exchange places. NaCl, aqueous. We'll start our sentence by saying aqueous sodium chloride. The plus sign is reacts with, so we have a verb. I see aqueous silver nitrate. Aqueous silver nitrate is AgNO3. And then I've got the arrow. So how about we say yielding? So we have a little different flavor here. Yielding. Aqueous sodium nitrate. And how about for the plus sign? We write and. And now I see an S, finally a new adjective. That's the driving force called a precipitate. Someday we'll learn how to read the solubility table and decide that that's our driving force, a solid little floaty chunky particle coming out of two aqueous solutions. The solid here's name is silver chloride. Aqueous sodium chloride reacts with aqueous silver nitrate, forming aqueous sodium nitrate and solid silver chloride, a double replacement pattern. One more to